Yeah, good evening. I hope you are able to see the screen and my voice is also audible. Can you please confirm me that?
Good evening, sir.
Yeah, hi, good evening.
Yes, sir. It's audible, sir. It's
Yeah,
clear.
fine. Thank you.
Yes.
Yeah. So in the last class, we were talking about the concept that is related to the hydration of cement. We have seen what is hydration of cement and what are the different hydration products that are available. And the structure of the hydrated cement is also focused on a little bit extent. So in today's class, what we are going to look is we'll be talking about what are the different physical properties of cement. And then I'll also be talking about how you are going to test these physical properties. Like suppose the strength is one physical property, the soundness is one physical property, specific gravity. So all these things we are going to talk, especially related to the tests that can be performed on cement. Now, before we talk about the testing of the cement, we need to understand why it is important to test the cement. So in order to identify the quality of the cement and also in order to check the various aspects, whether this cement can be used in a right proportion or not, whether this cement can be used for this kind of construction or not. To verify this kind of quality check or quality assurance, we are going to test the cement. So once after the testing of cement is completed, then only we can successfully implement it in the construction sites. Now, if you ask me, are we going to test the cement really in the construction site? Again, it depends. So if the site is a large scale construction project, then in that case, it is mandatory to go and test the cement, test the type of materials that we are going to use for that project. So that is called as we have a separate engineer called QA and QC team, quality assurance and quality control team. So those engineers will come and they'll be testing the quality of the materials, whatever we are going to use for the construction site or whatever we are going to use for the construction project. Now, the testing of cement, coming to the cement category. So the testing of cement can be done in two ways. The first one is testing the cement in the field condition, that is in the site condition, and the testing of cement in the laboratory condition. So we'll be talking about both these cases, how to test the cement in the field and how to test the cement in the laboratory, and how to verify or how to evaluate whether the test results, whatever we are getting, are there within the limits or not, and what are the code books that are used in order to identify or in order to check the quality of the material, that is cement. So first I'll be focusing on the list of tests and their test methods, especially when you are testing the cement in the field or in the site. So coming to the field test of cement, the very first test is called as color test. Usually we know that the color of the cement is a gray color. Okay, that's the typical color of any cement, whatever you take, especially the ordinary Portland cement. The cement will be in the color of gray. Now, whenever you get the cement bags into the construction site, it is important to check the color of the cement. And once you find out the color of the cement is gray, and you should also be verifying one more parameter, which is called as the color of the cement should be uniform. Suppose if you take a sample of cement, as it is showing in the figure, if you take a sample of cement in your hand, the color of the cement should be uniform. It should not be a non-uniform. Like some parts should not be white, some parts should not be gray, and some parts should not be some other color. It should not be in that way. So what it indicates when the color of the cement is not uniform. So when the color of the cement is not uniform, that means the quality of the cement is not appropriate. So you cannot use such kind of cement when the color is non-uniform. So remember that the color of the cement should be uniform, and especially the color of any cement, the ordinary Portland cement should be in the color of gray. So that's a typical color of cement. And the second one is called as a presence of lumps. Now you take any cement bag, in any cement bag, we'll get certain amount of lumps. Lumps are nothing but the hardened form of the cement. So when you store the cement for more and more number of days, in such scenarios, what happens is the cement will come in contact with the moisture. Again, the moisture which is available in the atmosphere only, not with the water that is available in the site. So whenever a cement is exposed for a more number of days to the moisture, during this exposure, what happens is some part of the cement will turn into the form of lumps. Lumps are nothing but a small stones. Again, you can crush these cement lumps. Again, some lumps can be crushed, some lumps cannot be crushed. But the thing what I would like to focus here is, whenever you get the cement bags, you should check whether that cement consists of lumps or not. Now, how these lumps are getting formed? These lumps are getting formed when you store the cement for a longer duration of time. And in the process of storing the cement for a longer duration of time, it comes in contact with the moisture that is available in the atmosphere. Now, in this case, the lumps will get formed. Now, whenever you have the cement which consists of lumps, that cement is not advised for the construction activities. So usually we see some cement, I mean, as soon as the structures will get constructed, maybe within 1 month or maybe within 6 months, the cracks will get initiated on the surface of the structure. So one reason for the crack initiation could be because of the presence of lumps. When you have lumps, that means that that cement is already exposed to the moisture. When the cement is already exposed to the moisture, it will not be available in the form of powder. It will be available in the form of small cement lumps, such as small cement stones, you can say. So these things are very bad for the construction activities. So such kind of cement bags which are filled with lumps are not advised for the construction of the structures. That's the second test that you can perform in the field. And the third test is the adulteration test. Now, what is this adulteration test? So whenever you get the cement bags into the site, so just take a pinch of a cement. Okay, just take a pinch of the cement. You can see in the image. So a cement sample is taken into your hands, and you should rub the cement between your fingers. Okay, you should rub the cement in between your fingers. You can see a person is rubbing the cement in between his fingers. Now, when you rub the cement, if it feels rough, okay, if it feels rough, what it indicates is that cement is mixed with some kind of sand. Okay, some small, very finite amount of sand, very small size of sand will be available. So in such cases, when you feel the roughness, when you are rubbing the cement, in such scenarios, you can understand that that cement is mixed with some additional third-party materials. Usually, those third-party materials are sand only, that is fine aggregate. So such kind of cement is called as adulterated cement. So it is not a pure cement, it is mixed with some kind of additional materials which are not advised. Okay, which are not advised. So why these materials will be added? Because to save the cost during the production or to make some additional profit for the by selling the such kind of cement bags. During these kind of times, they will use, I mean, the people will go for such kind of scenarios. So whenever you get the cement bags into the site, the first thing that you should do is take a sample of cement and you should rub in between your fingers. When you feel any roughness while rubbing the cement, it means that cement is adulterated with some third party materials. It can be sand, it can be any other materials also. So that's called as adulteration of cement. And the next one is called as a temperature test of cement. Now you might ask me that how will we test the temperature of a cement? So here we are not going to use any additional devices. What we are going to use is, as soon as we get the cement into the site, we are going to dip our hand into the cement bag. Okay, we are going to dip our hand into the cement bag. You can see here. This test involves inserting the hand into the cement bag to check its temperature. And as soon as you dip the hand into the cement bag, you should feel coolness inside the cement bag. If you feel any other thing other than the coolness, that cement is also not a good cement. Okay, so as soon as you get the site, you get the cement into the site, you are going to insert your hand into the cement bag, and if you feel coolness inside the cement bag, that cement is a good quality cement. That's how you can verify the temperature of the cement. Okay, that's how you can verify the temperature of the cement. You can see here, if you find warm temperature inside the cement bag, what it indicates is, it indicates that the process of hydration is taking place. Okay, the hydration process, the hydration products. I was telling in the last class that we have different hydration products like C3S, C2S, C3A, C4AF, etrilzite, monosulfate, and then the calcium. Hydration products only. Okay, all these are hydration products only. So in this cases, find any warmth inside the cement bag, it indicates there is still the hydration process that is taking place inside the cement bag. So whenever you get the cement bags into the site, it is better to store the cement bags in a proper condition where the moisture will not be available. Okay, it is better to store and cool the cement bag before you are going to actually use it for the construction. That's the fourth test. And the next test is called as a float test. Now in this test, what we are going to do is we are going to take a sample of cement. You can see in the image, you are going to take a sample of cement, and that cement we are going to throw it into the bucket full of water. Okay, we'll take a bucket full of water and we'll take a sample of cement and we are going to throw it into the bucket full of water. Now what happens as soon as as soon as you throw the cement into the bucket, what it should feel like is the cement particles should float for some time before they are going to sink. Immediately they should not sink. Okay, immediately they should not sink. As soon as you throw the cement particles or as soon as you throw the sample of cement into the bucket full of water, first they should float for some time. Again, if you ask me what is that some amount of time, is there any indication that it should stay for 2 minutes, 3 minutes, something like that? But there is no clear cut indication for that, but you should be visually able to see whether the cement is floating at least for 15 to 20 seconds on the surface of the water. After 15 to 20 seconds or 25 seconds, it can go inside or it will sink inside. Okay, that should happen. So immediately it should not get sink. That's called as a float test. This is also one of the tests that you can perform in the site condition or in the field condition. And the last test that we are going to perform in the site condition is setting test. Now in this test, what we are going to do is we are going to prepare a thick amount of cement paste. Okay, we are going to prepare some quantity of cement. Let's say some 100 grams of cement we are going to take, and with the 100 grams of cement, we'll use approximate quantity of water or appropriate quantity of water, and then we are going to make a paste. Okay, we are going to make a paste. And once this paste is prepared, what we are going to do with this paste is we are going to keep this paste on a surface of the glass plate. Okay, we are going to keep the paste on the surface of the glass plate. Now, once you place the cement paste on the surface of the glass plate, then what you are going to do is you are going to take the cement paste which is on the surface of the glass plate and you are going to keep it inside the water, and the duration is 24 hours. So you are going to take the cement paste which is on the surface of the glass plate and you are going to keep it in the water for 24 hours of duration. And after 24 hours, the cement should set. Okay, you should feel the hardness in the cement, but if you feel any kind of cracks that are available on the surface, such type of cement is a bad quality cement. Okay, that's called as setting test. So in setting test, what we are going to do is we'll take a sample of cement and we'll use approximate quantity of water and then we'll prepare the cement paste. So once we prepare the cement paste, we are going to place the cement paste on the surface of the glass plate. So once you place the cement paste on the surface of the glass plate, you are going to take this entire setup and you are going to keep it in the water for 24 hours. And after 24 hours, you should find the cement should get set and it should not get any kind of cracks. If cracks are available, that means that cement is not a good quality cement. Okay, if the cracks are available, that cement is not a good quality cement. And the last test is called as a strength of a cement test. Now, how will you find out the strength of the cement paste? So in this case, what we are going to do is we are going to cast a simple specimen, okay, which is having a dimension of 25 by 25 by 200 mm length. Okay, 25 side and 25 mm other side, that is length and width, and the total length of the specimen is 200 mm. So 25 by 25 by 200 mm specimen you are going to cast. And this specimen you are going to immerse in water for 7 days. Okay, this specimen you are going to immerse in water for 7 days. And once the 7 days gets completed, what you are going to do is you are going to place the sample on the supports. Okay, you're going to place the sample on the supports. And remember, the distance between two supports is 150 mm. Okay, it should be 150 mm. So here what we are going to do is, let me draw a simple figure here so that it will be better so that it will be better understood. So we are going to make a cement sample in this way. Okay, 25 by 25 by, again, the picture is not exactly the rectangle shape, but just consider it as a proper rectangle. So you are going to prepare the block of the cement, which is with the dimension of 25 by 25 by 200 mm length. And then you're going to keep this entire setup in water for 7 days. Okay, for 7 days. After 7 days, what you're going to do is this cement block, whatever that is available, this cement block you're going to place on two supports. Okay, you're going to place on two support. Sorry, it should not be in this way. So you have the cement block, okay, and this cement block you're going to paste it on the two supports, and the distance between the two supports should not exceed 150 mm. Okay, it should not exceed 150 mm. So that means the supports should be placed at a distance of 150 mm. And once you place the supports, what you are going to do is you are going to allow a weight of 34 kilograms on the specimen. Okay, you're going to put 34 kilograms of weight. And if the cement block, okay, if the cement block does not get fail, then you can call such kind of cement as a good quality of cement. Okay, if you keep 34 kilograms of weight on the surface of the cement block, the cement block should not get fail. So in that case, what happens is you can verify that, or you can qualify that that quality of the cement is very good. Such kind of cement it is used for the construction activities. And the very last one, which is again the most important one, is the date of packing. So whenever you get the cement bags or whenever you order the cement bags into the construction site, the very first thing that you have to verify is the date of packing. So when it was packed and when it is going to get expired. So these two things are very much important. If you find the packing date as beyond the limit, once you get any expired cement bags, so such cement bags cannot be used for the construction activities. It's same like when you go to a medical store, you will ask for a tablet and they will give you some tablet or they'll give you one capsule. And then the first thing that you have to verify is the date of expiration. So once you find that the tablet or the capsule has got expired, then you cannot use such kind of capsule for the for us or for the healthy case. So in such case, what happens is when you use such kind of tablets which got an expiration date, they will give some additional more health problems. So similarly with cement also. So these are the 8 different types of test of cement that you can perform in the field. Okay, that you can perform in the field. Now let's look at what are the different tests that we can perform in the laboratory conditions. So there are almost 7 to 8 different tests that you can perform on the laboratory conditions. The first one is called as a fineness of cement, followed by the setting time of cement, strength test, soundness test, specific gravity test, heat of hydration, and chemical composition test. These are the 7 tests that you can perform in the laboratory. Now, again, among all these 7 different tests, the most important ones are the first to fifth. Okay, so you have to do the fineness test, the setting time test, strength test, soundness test, and specific gravity test. So these two tests, that is heat of hydration and chemical composition of test, you can do it, but only when you have the advanced equipment in the laboratory. So I was telling in the last class, if you want to find out the hydration of the cement, or if you want to verify the hydration of the cement, we are going to use a calorimeter, adiabatic calorimeter, or a calorimeter will be used to find out. Yeah, so there was some network issues, I guess. Yeah, so the 6th and 7th test can be performed only when you have the advanced equipment in your laboratory. Apart from that, you can perform these first 5 tests with the basic requirements of the uh, apparatus. Okay, here I'm going to talk about only the first 5 things because I have already discussed about the 6th and the 7th test when I was talking about the concept of hydration. Okay, in that case, I was mentioning about the how to find and how to define the chemical composition of the cement. Okay, so first let us talk about the first test, which is called as a fineness of a cement. Now, what does it indicate? So what does this test indicate? So this test basically indicates the fineness of the cement, whether the particle sizes that are available in the cement are within the appropriate range or not. So it indicates basically the particle size of the cement. Now, do you have or do you want the particle sizes to be larger? No, we don't want the particle sizes of the cement should be larger. So what happens if the particle sizes of the cement is larger? Then such kind of cement is not good for the construction activities. So in order to find out the particle size of the cement, we are going to use a test called fineness of cement or fineness test of cement. Now, if you ask me, is this test very important? Yes, it is important. But in what way? So this test basically gives a direct result or gives a direct indication of rate of hydration, whether hydration will happen at a faster pace or not, whether the cement will attain the strength or not, and whether it liberates enough amount of heat or not. So these things these three parameters, we can identify or we can quantify based upon the particle size. If the particle size is very less, the heat of hydration will be very high. So the hydration process will also be very good. And if the particle size of the cement is very small, then the strength gain of the cement will also be very good. Again, there is a problem that comes with when the particle size of the cement is very, very small, there is again a problem with that scenario. Okay, we cannot tell that all the cements will have the very fine amount of particle sizes, but it should have the proper fineness. I'll be talking about that. Once I explain the test process, you will be identifying what should be the appropriate size of the cement particles. So I was mentioning what happens if you find more finer particles in the cement bag. So if you find more finer particles in the cement bag, the 28 days compressive strength of the concrete will get increased. So there is no problem with it. Finer the cement, the more will be the strength. But the problem is when you have the fine particles of the cement, there is a problem with the shrinkage. What is the shrinkage? Shrinkage means the change in the volume of the structure or change in the volume of the specimen or member. Again, related to shrinkage, we'll be talking about this shrinkage parameters in the fourth unit, that is in the fourth module. So I'll be talking in detail about what is shrinkage, what is drying shrinkage, all these things. But for time being, you just remember that whenever you have the finer particles that are available in the cement, it might give you the good strength, but the problem is it will lead to the shrinkage parameter. Now, what happens when shrinkage happens? When shrinkage happens in the structural member, you will find cracks on the surface. Okay, you'll find cracks on the surface. Also in the deeper layers of the concrete structure or the concrete member, the cracks will propagate into the deeper layers. So that's the problem with when you have higher fineness of the cement particles. Now, what is the usual size of the cement particles is any cement bag should have a size less than about 100 microns. Okay, any cement bag or the maximum number of particles in a sample of cement should have a size less than 100 microns. That's the typical size range. Okay, that's the typical size range. Any cement particle, or if you take a sample of cement and if you do the fineness test of cement, it should have a size less than 90 microns. If the sample is greater than 100 microns or greater than 90 microns, then that type of cement is not advised for the construction activities. Now let's verify whether the cement can be tested in what way or not. So you can see here about 10% of weight of the cement should be greater than 50 microns, and only a very few percentage weight of particles are larger than 90 microns. Okay, though the condition is telling that it should be less than 100 microns, but typically what we use is we'll go with 90 microns only, not with 100 microns. 100 is the upper limit, but 90 microns is the limit which we generally follow in order to find out the fineness of the cement particles. Okay, in order to find out the fineness of the cement particles. So in commercial cement, whatever the cements that we generally have, in commercial cements, it is suggested that there should be about 25 to 30% of the particles of size less than 7 microns should be available. Okay, if you take 100% of the cement bag, in that 100% of the cement bag, 25 to 30% of the cement particles must have a size less than 7 microns. Okay, less than 7 microns. Again, it's a limitation. Okay, 25 to 30% only. So what happens if you have more amount of fine particles? More amount of fine particles will give you better strength, but at the same time, it will give you shrinkage, which ultimately leads to the cracks on the surface of the member and also in the deeper layers of the member. Okay, fine. So the fineness of the cement basically measured in two different ways. The first test is called as a sieve test, and the second test is called as Blaine's air permeability method. Okay, Blaine is the name of a scientist. So we are going to find out the fineness of the cement using these tests, sieve test and also the Blaine's air permeability method. Okay, the Blaine's air permeability method. So here I'm not going to focus on Blaine's air permeability method. It's an advanced test. I'll be talking that in the 5th unit. Okay, whenever we are going to talk about the different types of advanced testing methods of cement, in that case, I'll be talking about how to find out the fineness of the cement based on Blaine's air permeability apparatus or Blaine's air permeability test. Anything is same. Okay, fine. So first, let us find out the fineness of the cement based on the sieve test. Okay, so in sieve test, what we are going to do is we are going to take some set of sieves. These are called as sieve samples. Okay, I hope you are aware of how these sieve samples will be available. So we are going to take this set of sieves, and here, in order to find out the fineness of the cement based on the sieve test, we have this particular code, which is IS 4031 part 1. Okay, based on this particular code, we can find out or we can determine the sieve analysis of the cement, or we can perform the sieve test of cement. Let's see how to find out the fineness of the cement particles that are available. Now, the question is why we need to do this test. It is obvious that we want to find out the cement particles which are having a size larger than 90 microns. I was telling, though the 100 microns is the upper limit, we are going to restrict that upper limit to 90 microns only. So whenever you do the sieve test, what you're going to take is, you're going to take a sample of sieve which is having a size of 90 microns. You can see this, you can see the grid sizes here. So between the three grids, you can see the sizes of the grids are getting varied. So in this case, you can see the larger size of the grids. That means it is the size is very high for this. You can see here it is a little smaller when you compare with this sieve. And with this one, it is much smaller than these two sieves. So based upon the grid size, we are going to quantify whether the cement particles are having appropriate sizes or not. So in this test, what we are going to do is we are going to use a sieve which is having a size 90 microns. Okay, which is having a size 90 microns. I'll show you that. So you can see here the apparatus that are required are, we'll be taking a sample of cement, maybe 200 grams or 500 grams of cement we are going to take, or even 100 grams also it is fine. But it's better if you have the bigger samples, maybe 200 or 500 grams or 250 grams is sufficient, right? So we are going to take a sample of cement, and then we need the weighing balance to measure the weights. And then we are going to take the 90 micron sieve along with the sieve lid. Okay, its lid is nothing but a cap for the sieve. And then we are going to have the sieve shaking machine, or you can also manually shake it. There is no problem. You don't need the mechanical sieve shaker, especially when you are doing the test for cement. Manual sieving is sufficient, right? So now let's look at the procedure here. The first thing that you have to verify is, whenever you are taking a sample of cement to find out the sieve analysis or to find out the fineness of the cement, make sure that the cement should not consist of any kind of lumps. Okay, the cement should not consist of any kind of lumps. That's the first thing you have to verify. If the cement consists of lumps, or if the sample of cement consists of lumps, those lumps you have to throw it away. Only the cement particles you have to take, not the lumps. So once you take a sample of cement, what we are going to do is, we are going to take a sample of cement with weight of 100 grams. That's the sample of cement that we are going to take. 100 grams or 200 grams, 250 grams is also sufficient, no problem. Okay, so that weight we are going to define it as a W1. Okay, that weight we are going to define it as W1. W1 is the weight of a sample of cement. And then what we are going to do is, we are going to take the 90 micron sieve, and then we are going to pour this cement sample onto the 90 micron sieve. Okay, we are going to pour this cement onto the 90 micron sieve. And then if the sieve shaker is available, you can keep the apparatus or you can keep the setup in the sieve shaker. If the mechanical sieve shaker is not available, you can just sieve the sample for at least 5 minutes. Okay, you can sieve the sample for at least 5 minutes. And after 5 minutes, what you're going to measure is, you're going to take the weight of the sample. Okay, you're going to take the weight of the sample that is retained on this 90 micron sieve. Okay, you're going to take the weight of the sample that is retained on 90 micron sieve. See, I was telling that you have to sieve the sample for at least 5 minutes. Now, in the process of sieving, what happens? Some particles will flow through this sieve. Okay, some particles will be there on the top of sieve. So whatever the sample of particles that are available on the top of sieve, you're going to collect that sample and you're going to take the weight, or you're going to measure the weight. And that weight, you're going to call it as W2. Okay, and that weight, you're going to call it as W2. Now, how to find out the percentage of cement retained on sieve? So you can find out it as W2 by W1. What is W2? W2 is the weight of sample retained on 90 micron sieve, and W1 is the sample of cement which we have used to test. Okay, so W2 by W1 times of 100. Now, how to verify whether the value is within the limits or not? So you can see here, the amount of cement retained on 90 micron sieve shall never exceed 10%. Okay, if you get the value as a 10% or beyond 10%, then that cement is not a good quality cement. It is adulterated with sand, or it is adulterated with some third party materials. Okay, that's how you can infer, or you can quantify whether the cement sample is right for the use of construction or not. Okay, so the percentage of cement retained on each sieve or the sieve sample should never exceed 10%. Up to 10% it is fine, but if you find the value as 11% or 12%, then that cement is adulterated with sand, or that cement consists of some third party materials. Okay, some third party material. So that's how you can do the fineness of the cement, or you can verify the fineness of the cement particles in a sample of cement. Okay, that's about this test. So this is the entire process. I was just mentioning that in the pictorial way. So this is the entire process. So, and then we'll be looking after what is the importance of fineness of cement. I was telling, so when you have good amount of fineness, obviously you'll get the strength, but the problem is you will have the shrinkage cracks. Now you can see these are the importance of fineness of cement. It can decrease the bleeding and it can increase the final strength of the cement. Fineness can also affect the workability of the cement, and then fineness test directly measures the surface area of the particles of the cement per unit mass. So likewise, there are different importance in order to find out the fineness of the cement. So because of these reasons, we are going to verify, or we are going to do the fineness of the cement. Whatever that you get into the site, you have to send that cement sample to the laboratory, and then you have to get the results should get validated. Okay, the results should get validated. So that's about fineness of cement. And the next one is called as setting time test. Okay, or setting time of cement. Now, before we do the setting time of cement, we are going to do one test which is called as standard consistency or normal consistency. Okay, we are going to do this test called standard consistency or normal consistency. We cannot directly go and jump doing the setting time of cement. So first we have to do the standard consistency test, and based on the result that you are getting in the standard consistency test, that result you are going to use it for the setting time test. Now again, in setting time, we have two different types of setting times. One is called as initial setting time, and the second one is called as final setting time. I'll talk about that in some time. But first, let us focus on how to do the standard consistency of test. Okay, standard consistency of cement. But what is this consistency? Consistency is nothing but, suppose let's say that let's say you're like you are a fan of a cricketer. Now let's say that a cricketer, some ex-cricketer, is doing runs or is performing better and better in every match. Okay, let's say on the first ODI he had made a 50 runs. In the second ODI he had made, the same person had made some 100 runs. In the third ODI the same person has made some 120 runs or 130 runs. So now what does it indicate? The consistency is there. Every match the performance is getting increased. Okay, every match the performance is getting increased. That's called as a consistency, without losing the minimum runs or without losing the minimum mark. He is performing, that cricketer is performing on a good level. That's called as consistency. Similarly, in cement, consistency can be defined as ability of the cement paste. Okay, ability of the cement paste to flow. Okay, whenever you prepare the cement paste, that cement paste should flow on its own. That ability of the cement paste to flow is called as consistency. Okay, the ability of the cement paste to flow is called as consistency. So here you can use the cement paste or the mortar also. I told you the cement paste consists of just cement and mortar, cement and water, and mortar consists of cement and then fine aggregate and water. That's the difference between cement paste and mortar, right? So why this test is done? So this test is basically made to find out how much amount of water is required to produce a cement paste. Now, in the very first test, I was mentioning that, I mean, in the adulteration test or in the field test, I was telling that you can take a sample of cement and you have to mix the appropriate quantity of water or approximate quantity of water. Now, there I was mentioning that approximate quantity. I was not telling that exactly this much quantity of water you have to use. But in setting time of test, you will be able to find out what is the exact quantity of water that is required in order to prepare a cement paste. Okay, in order to prepare a cement paste, what is the exact quantity of water that is required? That exact quantity of water requirement can be determined by using the standard consistency test. Okay, by using the standard consistency test. Now, in this test, we have three different needles. Okay, we have one apparatus which is called as Vicat apparatus or Vicat apparatus. I'll show you that. But this Vicat apparatus, what it consists is, let me show you this. Yeah, so this is the Vicat apparatus. So you can see a reading scale will be there, and you can see a small cement paste mold, and there is a glass plate, and you can see three needles that are available. Okay, there are three needles. I'll just show you that. So the first needle is called as a plunger. Okay, the first needle is called as plunger. Now you can see the diameter of this needle is very large. Okay, the diameter of this needle is very large. This is the needle that you are going to use in order to do the standard consistency of cement. Okay, in order to perform the standard consistency of cement, we are going to use this needle. So how we are going to use this needle is, you can see the thread portion that is there at the bottom. This needle will be attached to this sample or to this apparatus or to this setup. Okay, you can see the screw, a small screw. So you are going to lose that screw and you are going to fit this entire plunger into this screw part or into this apparatus setup. And this is one thing, the plunger. And the second one, we have a needle which is called as initial setting time needle. So this needle, the needle at the top, is called as initial setting time needle. And we have one last needle which is called as final setting time needle. Okay, these are the three needles that you are going to use in order to find out the standard consistency, in order to find out the initial setting time, and in order to find out the final setting time. So here the diameters of the needle gets varied based upon the test that you are going to do. Okay, based upon the test that you are going to do, we are going to use different needles. I'll talk about this, which needle has to be used and in what way we have to use, that I'll talk now. So as we are going to focus on the standard consistency of cement, so here what we are going to do is, we are going to take the Vicat apparatus and you can see the plunger is attached. Okay, you can see the plunger is attached, and then you can see the cement paste mold. That mold is called as Vicat mold. And this Vicat mold has to be placed on the surface of a glass plate. Okay, surface of a glass plate. Now, how you are going to do this test is, we are going to take a sample of cement. Okay, we are going to take a sample of cement. Now, what this test is meant for, the standard consistency test is meant to identify or to find out what is the exact quantity of water that is required to prepare a cement paste, right? To find out the exact quantity of water that is required to find out the quantity of water for to prepare the cement paste, right? So now here I'm going to take the 500 grams of cement, and this cement, okay, this 500 grams of cement, we are going to take a sample of water. Now how much quantity of water we are going to take? So here we are going to take a sample of water by the percentage of weight of cement. So here first you are going to you're going to start the testing process by using 24% of water. So that means here you're going to take 500 grams of cement and you're going to take 24% of water content. So here, what is the cement content? Let me write this. So the cement content is 500 grams. Okay, the cement content is 500 grams. And the water content that you're going to take is 24% of 500 grams. Okay, 24% of 500 grams, 24% times of 500, whatever is the value that you are getting. So let's say the value is called as x1. Okay, I'm just making the value as x1. So based upon this value is your water content. Okay, this x1 is your water content. Now, what you will do, this water content, whatever the x1 value that you are getting, that water content you are going to take, and then you are going to prepare the cement paste. Okay, and then you are going to prepare the cement paste. So once you prepare the cement paste, what you are going to do is you are going to prepare the cement paste, and that cement paste we are going to fill it in the Vicat mold. You can see the Vicat mold here. On this, into this Vicat mold, we are going to fill the cement paste. Okay, into this Vicat mold, we are going to fill the cement paste. Now, up to what level we have to fill it? We have to fill it up to the surface of the Vicat mold. Okay, up to the surface of the Vicat mold, we are going to fill it. You can see here, the paste is prepared and it is filled in the Vicat mold within 3 to 5 minutes. You should not take longer duration of time to prepare the cement paste. Within 3 to 5 minutes, you have to finish the preparation of the cement paste, and you also have to fill it inside the Vicat mold. Okay, inside the Vicat mold, you have to fill it within 3 to 5 minutes. Now, after completely filling the Vicat mold, you are going to make the surface as a flat surface. How you are going to make? You are going to shake the mold. Now, when you shake the mold, what happens is, remember, in the process of shaking, the mold should be on the surface of the glass plate only. You are just going to take the glass plate and you are just going to move it. That's it. Nothing much you are going to do. So what happens when you do this kind of shaking is it expels any kind of air that is available. Okay, if there is any amount of air that is available, it expels that amount of air that is available in the cement paste. Whatever the cement paste that you have prepared, it will expel when you shake the mold. Now, after you shake the mold, what you're going to do is you're going to take the plunger. Okay, you're going to take the plunger, and the plunger diameter is 10 mm, and the length of the plunger is 50 mm. You can yeah. So 10 mm is the diameter of the plunger and 50 mm is the length of the plunger. Now, once you are going to attach the plunger to the setup, to the Vicat apparatus setup, what you are going to do is you are going to release that plunger into the Vicat mold. Okay, you're going to release that plunger. I'll just show you one thing. So just give me a second. I have one image. Yeah. So one video is there. I'll just play this video so that you'll have an better idea about this. Just give me a second. I think video is available, but why it is not? Yeah. So you can see the video part. Yeah. So you can see the video part so that you'll be able to understand. So there are two types of setting of cement: initial setting time and final setting time. So you can see what is this initial setting time. Initial setting time is regarded as the time elapsed between the moment that water is added. As soon as you add the water, okay, as soon as you add the water, what happens to the cement particles? The cement particles usually will be available in the form of powder. Now, when you add water, what happens? It will turn into the form of paste. Okay, it will turn into the form of paste. So that stage is called as initial setting time. Okay, that stage is called as initial setting time. Converting the cement powder into the form of a cement paste is called as initial setting time. And then final setting time, it is the process, or it is the time elapsed between the moment the water is added to the cement and the time when the paste has completely lost its plasticity. What is this plasticity? So in the initial setting time, what happens is if you take the cement, you can make the cement, or you can feel that cement paste. Okay, you can take that cement paste and you can feel that cement paste. But final setting time is the time where the cement will start setting. That means the cement will start getting hardened. That's called as losing its plasticity. Once the cement loses its plasticity, then the cement will get set. That is called as a final setting time. Okay, that is called as final setting time. So that's the difference between initial setting time and final setting time. Yeah, so this is the Vicat apparatus. Okay, this is the Vicat apparatus. You can see the plunger which is attached here and the Vicat mold that is available. And here the process is being explained. We are going to take 500 grams of cement sample and then we are going to use 0.85 times the water. Again, to produce the standard consistency. I was mentioning that 24% of water. So initially you have to try with 24%, 26%, 28%. Likewise, you have to try. And then you're going to use 0.85 times the water that is required to produce the cement paste for the standard consistency. Okay, you're going to use the water with 0.85 percentage. And you're going to prepare the cement paste. Once you prepare the cement paste, you're going to fill it into the Vicat mold and make sure that the surface of the Vicat mold should be a leveled surface. And then you're going to place the needle. Okay, you're going to place the needle. And then what you're going to do is you're going to allow the needle to go inside. Now you can see the reading is observed here. Okay, you can see some reading is observed here. That reading we have to note down. Okay, every 2 minutes we have to note down that reading, and that reading will be any reading. It can be any reading. Okay, it can be any reading. So here it is like 5 plus or minus 0.5 mm, but you should be measuring the needle reading exactly. Okay, you should be measuring the reading exactly. And you can see the time period elapsed between the time when water is added to the cement and the time at which the needle penetrates the test block to a equal depth of 5 plus or minus 0.5 mm from the top is taken as initial setting time. So when the time of penetration, okay, is at the depth of 5 plus or minus 0.5 mm, so that reading we are going to define it as initial setting time. Okay, that reading we are going to define as initial setting time. Then what we are going to do is we are going to change the needle. Okay, we are going to change the needle, and here we are going to use the larger needle. Can you see the larger needle in order to find out the final setting time? Okay, in order to find out the final setting time, you can see the needle type. I was just showing the 3 different needles, plunger and the other 2 needles for initial setting time and final setting time. And then this needle, is also to be released into the cement paste. Okay, this needle is also to be released into the cement paste or the Vicat mold. And then what happens is you will get the reading. Okay, you will get the reading. And here you are going to note the reading in such a way that at some particular point, the central needle makes an impression while circular cutting edge fails. That means it will not go anywhere inside. After a particular time, first initially it will go into certain deeper level. After that, it will not go into any other depths. Then that point you have to note, or that reading you have to note. So usually the initial setting time of cement will be obtained at the end of 30 minutes, and the final setting time of the cement will be obtained at the end of 10 hours. 10 hours or 60 minutes, or sorry, 600 minutes. So that's the initial setting time and final setting time of the cement. I hope it is clear. So the initial setting time and final setting time. So here, let's talk about the difference between what is setting and what is hardening. So setting is nothing but, okay, setting is nothing but the cement paste will get stiffened. You can see here, the cement paste will be stiffer. It is not hardened. Okay, it is not hardened. So hardening is nothing but the cement or the concrete will get hardened. Now, can you reshape this one? So you can see the circular shape or you can see the cylindrical shape of the mold. Can you reshape this cylindrical mold? No, you cannot reshape. Why? Because the cement has got hardened, it has got strength. But when the cement is in the stage of setting, okay, when the cement is in the stage of setting or when it is in the stage of stiffening, you can take the cement paste and you can place it wherever it is required. You can change the shape of this cement paste because it is in the setting state only. Once the cement has completely lost its setting time, then the cement will turn into the hardened state. Once the cement turns into the hardened state, then you cannot have the change in shape of the material. So that's the difference between setting and hardening of the cement. In the setting case, we can change the shape of the cement paste. But once the cement gets hardened, you cannot change the shape of the mold or shape of the sample. That's the difference between setting and hardening of the cement. Now, let's look at one more test, which is called as a soundness of cement. So I was telling in the second class that the functions of lime, silica, alumina, and iron oxide. Now, what gives unsoundness to the cement? When you have excess amount of lime in the cement particles, okay, when you have excess amount of calcium oxide or lime in the cement, that gives unsoundness to the cement. Okay, that gives unsoundness to the cement. Now, let me show you this video which explains about how to do the or how to verify the soundness test on the cement. So you can see the apparatus here, that is, you can see the apparatus here, that is the Le Chatelier mold. Okay, Le Chatelier mold. This is the Le Chatelier apparatus or Le Chatelier mold. So you're going to take a glass plate and there should be some weight, some 10 grams or 50 grams of weight should be there. And this Le Chatelier apparatus is provided with two needles. You can see the two needles here, and it is with a small circular disc will be available. Okay, small circular disc will be available, or split cylinder disc, you can say. Now, what you're going to do is you're going to prepare the cement paste. Okay, you're going to prepare the cement paste. You can see the Le Chatelier test is used to find the excess amount of lime is available in the cement or not. I was telling. So unsoundness to the cement is because of the presence of excess lime. So when you have excess amount of lime, it leads to unsoundness to the cement. So initially we are going to take a sample of cement. Okay, you can see the sample of cement is being taken. So that's approximately 200 grams of sample. So you can see the process here. Just focus on the video so that it explains the process in a very detailed way. So that's the entire test process, and that's the condition of the value that you have to remember. So it was mentioning that we are going to measure the distance between two needles. Okay, we are going to measure the distance between two needles after 3 hours of keeping it in the water bath. Now, if the distance between the two needles, okay, if the measured distance between two needles is greater than 1 centimeter or 10 mm, then that cement is prone to unsoundness. That cement consists of excess amount of lime. So whenever you do the test, the cement sample or the difference between the two needles should not exceed 10 mm, okay, or 1 centimeter. This must not exceed 10 mm for ordinary Portland cement or rapid hardening cement and low heat Portland cements. So that's how you're going to do the soundness test of cement. And the next test is strength test of cement. So in this test, what we are going to do is we are going to prepare a cement cube which is with a dimension of 7.06 centimeters. Okay, we are going to prepare a cement cube, which is with a dimension of 7.06 centimeters. And then what we are going to do is we are going to test it for the compressive strength. Okay, here again, it's not just cement, it is a mixture of cement and fine aggregate. So you can call it as a mortar specimen. So you are going to take a mortar specimen, which is with a ratio of 1:3. That is 1 part of cement and 3 parts of fine aggregate, or 1 part of cement with 4 parts of fine aggregate. You can take either 1:3 or 1:4 ratio, and then you are going to prepare 3 cubes which have a size of 7.06 centimeters. Okay, you're going to prepare 3 cubes of size 7.06 centimeters, and then you're going to cure the specimens for 28 days. After 28 days, you're going to test for the compressive strength. Okay, after 28 days, you're going to test for the compressive strength. And once you test for the compressive strength, you should be able to find out the appropriate strength, whatever is required. Suppose if you are testing it for OPC 53 grade cement, then the minimum strength should be 53 megapascals. You should get minimum 53 megapascals. Suppose if you are testing 43 grade of, if you are using OPC 43 grade of cement, then the minimum strength should be 43 megapascals for the cement. So that's how you are going to use the strength test on cement, or you're going to define the strength test of cement. And the last test is called as specific gravity of cement. So in this test, we are going to use an apparatus which is called as specific gravity bottle. Okay, in this test, we are going to use an apparatus which is called as specific gravity bottle. You can see the specific gravity bottle. So initially, what we are going to do is we are going to take the empty weight of the specific gravity bottle. Okay, empty weight of the specific gravity of bottle, and that weight we are going to call it as W1. Okay, that weight we are going to call it as W1. And then we are going to take 50 grams of cement. Okay, we are going to take 50 grams of cement, and that 50 grams of cement, we are going to pour it into the flask. That is gravity bottle flask or specific gravity bottle. Okay, we are going to pour it into the specific gravity bottle. And then we are going to take the weight. So what is this W2? W2, sorry. So W2 is the weight of the flask which is filled with 50 grams of cement. Okay, W2 is the weight of flask which is filled with 50 grams of cement. And then what we are going to do is we are going to pour the kerosene into the specific gravity bottle up to the surface of the neck. That is, up to this surface, we are going to pour the kerosene. Okay, up to this surface, we are going to pour the kerosene, and then we are going to measure the weight. And that weight, we are going to call it as W3. So W1 is the empty weight of the flask. W2 is the weight of the flask with 50 grams of cement, and W3 is the weight of the flask, 50 grams of cement, and also which is filled with kerosene. So you have got three different weights. And once after these three different weights are collected, you are going to throw that entire sample. In the next case, what you're going to do is you're going to fill the kerosene in the specific gravity bottle up to the neck. Okay, up to the neck, you're going to fill it with the kerosene, only with kerosene. That weight you're going to take it as W4. Okay, that weight you're going to take it as W4. So here you have got four weights: W1, W2, W3, and W4. So by using these four weights, we have a formula where we are going to substitute, and hence we are going to get the specific gravity of cement. Okay, we are going to get the specific gravity of cement. Usually, the specific gravity of cement will be lying in between 3.12 to 3.15. Okay, usually the specific gravity of cement will be lying in between 3.12 to 3.15. Even if you get 3.11 also, it is fine. But the typical range is 3.12 to 3.15. So these are the different tests that you can perform in the laboratory on cement. Okay, in the laboratory on cement. So we have seen the fineness of the cement, the standard consistency of cement. In the standard consistency, we have seen the initial setting time and final setting time. We have also seen the soundness test of the cement. We have also seen the strength test of the cement. And the last test is specific gravity of cement. So these are the 5 tests that need to be done in order to evaluate the quality of the cement. And if you ask me which is the most important test that we are going to do is the specific gravity of cement. Again, it depends, but I cannot say exactly say that we have to do only the specific gravity of cement. But mostly, whenever you are working on a project in the laboratory conditions, it is important to find out the specific gravity of cement. Along with specific gravity of cement, you can also find out the fineness of the cement. Okay, fineness of the cement. Soundness of cement test, it is an optional case. Only when you have a requirement in your project you can do that. Otherwise, specific gravity and fineness of the cement are the two most important tests that needs to be done, especially in the laboratory conditions, right? So this is all about the cement. So with this, we have completed the topics, or we have completed the concepts that are related to the cement. In the next class, that is in the tomorrow session, we'll be talking about the second module in the first thing, which is called as admixtures. So I'll be talking about what is this admixture, what are the different types of admixture, how to work with all these different types of admixtures. We'll be talking about all these things in the next class. Okay. So if you have any doubts, I'm ready to take your doubts. Before that, just give me a second. So I'll stop the screen sharing so that you can ask the doubts. Yeah. So that's from my end. If you have doubts, now you can ask your doubts.
Sir, about the grading of the cements, the grades of the
Yeah.
cements.
So we have basically three different grades of cement. I mean, especially in the ordinary Portland cement, we
Sure.
have three different grades: OPC 33, OPC 43, and OPC 53. Now, if you ask me, what is the importance of each grade of cement is, the importance comes with the strength. Here, 33, 43, and 53, they represent the compressive strength of the cement. Okay, the OPC 33 means 33 megapascals of cement strength will be there for that cement. OPC 43 means 43 megapascals of strength will be there for that cement. OPC 53 means 53 megapascals of strength will be there for that cement. Now, if you again ask me which type of cement we are going to use, is it OPC 33, 43, or 53? Usually, OPC 33 is no longer available. Okay, it is no longer being manufactured by the companies. So the type of the cement which is being manufactured or which is now available is OPC 30, OPC 43 and OPC 53. Again, the OPC 43 is not widely available. It is only available in a specific places. So we cannot tell that in which places it is available. It depends on the manufacturer. But OPC 53 is something which is widely available and it is also widely used. It is also widely used. I hope I have answered your question.
Sir, in Africa, we are using superset 32.5 and 43.5.
Okay.
So instead of 33 and 43. So
Okay.
my question is actually why they will take only 32 and 43? Like why they are not taking some other digits like 18, 20, 22,
Yeah.
30? Like,
The reason is, suppose let's say you have the cement with uh, OPC 18, OPC 19, OPC 20, OPC 21. Likewise, it is there. Now, what is the difference between OPC 18 and OPC 19? Hardly 1 megapascal of strength is the difference. Nothing much. So
okay.
just for 1 megapascal of cement, you cannot manufacture completely a different cement. So for that, what the scientists have done is they have made some ranges with a range of 10 megapascal. That is why the first they have started with OPC 33, and then with the 10 interval of difference, we have got another grade, that is OPC 43, and with another 10 interval, we have got OPC 53. So in the olden days, when we don't had this OPC 43 and 53, people used to use only OPC 33 because that's the maximum strength that is available for us. Then as the requirements got increased, as we started constructing the multi-story buildings, the tall structures, all these things, the OPC 33 cement is no longer helpful for them because OPC 33 will have only 33 megapascals of strength. So in such cases, they had to go for higher strength to the cement. So that's how they have come with OPC 33, 43, and 53.
Okay.
Again, if you ask me like is it the same? I mean, do you find OPC 33, 43, and 53 across the globe? No, it is not that way. So based on Indian standards, we have these three different grades in OPC. If you ask me in US standards, they have different grades, SEM 1, SEM 2, SEM 3. Likewise, they have different grades. In African standards, they might have some other different standards. In British standards, they will have some other types of standards, right? Type 1, type 2, type 3 type of cements. So in European, they will have, it depends on which country you are working on, and each country will have their own standards. So in India, we have Indian standards. For American, they'll have the ASTM standards. For British, they are having British standards, BS standards. So it depends on the country which you are working, or country which the cement is being manufactured.
Okay. So process is
Yeah.
same.
Yeah. Process is same. There is no
Okay.
much difference.
Sir, another question. What is the main priority for the curing? Why we have to do the curing after concreting?
See, thing is like, suppose let's say you have the fresh concrete, the concrete which is just now mixed. So usually the fresh concrete, what happens is it will be poured. Suppose if you take a sample of fresh concrete, if you pour that concrete into the rectangle shape, now the concrete will attain the shape of a rectangle. If you pour the concrete in a circular shape, that concrete will attain a circular shape. If you pour it in a square shape, it will attain the square shape. Now fine, let's say that you are casting a column, or you are casting a beam, or let's say you are casting a column. Usually the column will be available either in the square shape or in the rectangle shape, or sometimes in the circular shape also. Let's consider that you are casting a rectangular shape column. Now what will you do? You are going to place the formwork in the rectangle shape. Okay, you're going to place the formwork in the rectangle shape, and then you're going to pour the concrete. Now, what is the state of the concrete? The concrete state is, initially the concrete state is in the fresh state. That means if you don't have the formwork, the concrete will go anywhere. Okay, the concrete will go anywhere. You have to restrict that concrete to avoid the flow of concrete. Okay, to avoid the flow of concrete, we have to restrict that mold. Now, the thing is, why we need to do the curing? Suppose whenever the concrete structures are exposed in the process of constructing, suppose let's say you have constructed a column for the structure. Now, what happens? This column will be continuously exposed to the atmosphere. Now, what is this atmosphere? In this atmosphere, you have the cool temperature, you have the high temperature, you have the moderate temperature. Depending upon each day, the weather will get changed. Okay, depending upon each day, the weather, maybe today you might have 30 degrees centigrade. Tomorrow you might have 35 degrees centigrade. Day after tomorrow, you might have 40 degrees centigrade. Now, because of the change of weather, what happens with the water that is available in the concrete? That water will get evaporated. Over a period of time, the water will get evaporated because the concrete is in the fresh state, and when the water that is available in the concrete is getting evaporated, what happens? You will have the air voids, or you will have the water voids. Now you have a sample of water, and this water is getting evaporated. Now wherever the water is getting evaporated, there you will have the small spaces, or the voids will be there. Those voids are called as water voids. Now, is it good to have the voids inside the concrete structure? Obviously, we don't need the voids in the concrete structure. What happens if you have the voids in the concrete structure? Obviously, the strength of the concrete member will get decreased. So to avoid this continuous evaporation, we are going to do the curing. Now, when you do the curing, what happens is you are continuously supplying the water to the concrete structure, so that even if some amount of water is getting evaporated, you will still have some amount of water in the concrete. How this amount of water is available? Because you are externally supplying the amount of water. How you are supplying the external amount of water? In the process of curing. By using the process of curing, you are supplying additional amount of water, so that even if some amount of water is getting evaporated, you don't find the complete amount of water is getting evaporated. Some amount of water will, however, get evaporated. You cannot avoid that. But how much quantity of evaporation you are able to restrict that? That restriction can be done by using curing. And if you don't do curing to the concrete structures, what happens is the water will get evaporated. And because of the evaporation of the water, the concrete structures will have the voids. And because of the voids, the concrete structure will lose its strength. So that's how it gets interrelated. So curing is very much important in order to get the desired properties to the concrete.
Okay, sir, got it.
Yeah.
And sir, sometimes when we stock the cement in temporary rooms, so we
Okay.
see some type of cracks in the that walls.
Yes. Okay.
So why it will happen, sir?
So it might be because of improper finishing. Suppose in the room, suppose if you take a look into the room, whatever you are sitting, so in that room, some places are sometimes not, I cannot say your room is well finished or not well finished or not, but sometimes what people will do is due to poor workmanship, they will not do the surface finishing very properly. Okay, it's quite common. You cannot say that, suppose if you have some 10 floored buildings, for the same, for one floor, let's say two people are working. Now obviously, since it's a human involved work, people will feel restlessness, and they will have the negligence towards the finishing of the work. Now when they do improper finishing, what happens, the surface will be exposed to the natural atmosphere. Now when the surface is exposing to the natural atmosphere, obviously you'll have the cracks. That's one reason. When you do improper curing, then when you do improper finishing, then cracks will come. That's one reason. The second reason is when you do improper curing also. Suppose let's say you have some 10 columns that are available. Now you are going to cure the 9 samples every day. The 10th column you are not going to cure. Now what happens with the 10th column? Since you are not curing the 10th column, the water will get evaporated. Now when the water is getting evaporated, what happens inside the concrete? The voids will get formed. Now when the voids are getting formed, cracks will also get formed. That's how the cracks will get formed. When you do improper finishing and when you do improper curing, in these two cases the cracks will form. There is also a third scenario where the dampness is available. Suppose let's say a bathroom slab is available. Now bathroom is the place, or washroom is the place where continuously, at least more and more amount of times, the slab will be continuously exposed to water. If you don't do the bathroom finishing or the washroom finishing, what happens to the water that is available in the washroom? That will flow into the sides of the walls. Now, when the water is continuously flown into the sides of the walls, in the initial days, you might not find any difference. But when this happens at a regular basis, let's say it is going to happen for 10 days, 1 year, 2 years of time. Now, what happens? The water is continuously spread into the walls. Now, when the water is continuously spread into the walls, the surface of the walls will become very weak. Now, in that case, what happens? You will see the water surface, or you will see the dampness on the surface of the walls. And because of this dampness, what happens? Over a period of time, the wall will lose its strength, or the structural member will lose its strength. And ultimately, the cracks will get formed. And once the cracks are getting formed, the structure will get collapsed.
Okay, sir.
Yeah.
Right. Thank you, sir.
Yeah, fine. So we'll
Sir,
meet in the next class. Yeah,
sir,
please go on.
another question. Sorry, sir.
Yeah, please go on.
You are in IIT campus, right, sir?
I mean, I'm not getting your question.